Hello friends, I hope you can hear me well. My name is Mario, thank you for the thumbs up back there, very helpful. And today I will talk through passkeys through FIDO. So this will be an overview talk on like what is passkeys and which steps are involved for you to implement them yourself by hand. Right? And by hand means I'm going through all of the specifications I could come up with that are involved. Obviously there are more, but I'm also happy to talk about it with you later. And in order to talk to you about it later, all of my slides will be having my bit.ly link. Go through there, you will find those slides, all the contact details, and also the room in Matrix in here. If you have questions, feel free to ask them there. Find me anywhere, find me in person even. I'm happy to help us getting rid of passwords together. So let's start where we should usually be starting by what does the user want, right? We want users to not use passwords because passwords are inherently bad. We all can come up with at least 3 reasons why passwords are bad. So we want to have our user sign up with our fancy service that says, hey, you are signed up. Great service. You can tell by that I'm a backend developer. No, I'm actually doing Android development. So my focus will be for the first part on showing just how an Android app would work that uses passkeys. And once the passkeys are used successfully by the user, we will show an way that I'm going over into the screen. Perfect. And I can see my screen here now, and the user will be happy afterwards using our passkeys. But first, let's go for Android. The Android user uses the app. Amazing. So they started it. They enter a username and then ask the server, like, hey, is this username available? Once the username is successfully sent over to the server, this server will check into its database to see if it's available or not, and comes back with an answer whether it's available or not, and credential options. Those are options that tell our app and our authenticator later on what do we need in order to create the credentials and the passkey. Once we have those, we can give some options to the user and saying like, hey, so this is what the server said. Currently, your app can offer different options. You can use a hardware token, right? You have probably seen them running around to create a passkey, or you can use the Android OS options. Well, we, for some reason, decided that the user wants to use a hardware authenticator. Once the user selected the hardware authenticator, we need to configure this authenticator, give it the options, and then the authenticator creates a passkey, aka the public key credentials we need in order to successfully log in into the server. Well, since it's an authentication token, like a physical hardware that makes the processing of the public keys, we need to say like, hey, please enter a PIN so they can use the hardware authentication. So a beautiful Android UI, you can also see that I'm a programmer, not a designer, that shows, hey, please enter the PIN. And once we have the PIN, we can ask the credential creator, the authenticator, to actually do its job and create the credentials, send it over to the Android app, and then the Android app takes it over to the backend service. The service says like, hey, cool, I understand your public key now. The user can now be successfully logged in, and I can show that I'm actually an animator of slides. Okay, so this is the rough thing, that's what we want to do, but I want to go deeper and highlight a bit more what is involved in the chain to make this actually happen. This whole thing on the top level works by the specification called WebAuthn. WebAuthn is called web authentication. I'm not sure why they decided for this name, but this is the way they chose. So WebAuthn is the thing that guides the whole ceremony, what we're just doing. It's an API that is developed by the FIDO Alliance and the World Wide Web Consortium. Both of them came together and said like, hey, we need to standardize this somehow to make sure that we are getting further and further into the security of our users and our backend services. But what is the FIDO Alliance? FIDO stands for Fast Identity Online, and has like all of the members you can think of, right? So like there's Google, there's Apple, there's my compliant company, Yubico actually involved there, small companies, big companies, everybody who wants to be part of defining how specifications work to make you safer are in there. And they also have an overview document, which is the second link in the FIDO Alliance blob, that actually helps you understand what is the WebAuthn and more than what I was able to do right now. So FIDO Alliance teamed up with the V3C and said like, hey, we need to make it an official standards that browsers implement and we can actually use wherever a browser works. So together they built this beautiful specification over there, which by intention you cannot see right now, but it's just the excerpt of how the specification would look like that you can actually find under the WebAuthn link over there. And this defines, like I said, the ceremony, right? So how would the browser interface look like so that I can call and create and see whether a credential is created? But let's take a look at the specification, just a bit bigger and a bit less pixels, or a bit more pixels in this case even. So this is the options I was mentioning before, right? So if you have seen specifications before, I hope this looks kind of familiar because it's literally defining how the object looks like if you want to create it in a JSON object. It's called public key credential creation options because that's exactly what it does, right? We need the options to create a public key on an authenticator. The beautiful thing about those public key credentials is that they are a passkey. And a passkey is a public key credential that is linked between a user and a relying party, right? So you cannot use the same public key between different users for the same endpoint or relying party, or between the same user and different relying parties. They are all unique. The link between user, public key credential, and relying party. Also, I keep mentioning relying party. Think of the relying party as the backend, right? It has a URL, it has an endpoint, and we are calling it RP and T in here. You can click through this more and see like what a relying party, public key credential entity actually looks like, but I think I want to focus on other things for now. So I was saying passkeys link users with the relying party. Obviously, we also need the user inside of this object. So this would be the second field we are seeing here. And since it's public key encryption, and we want to make sure that the authentication and the authenticator does the right thing, we also from the backend need to give over a challenge. The challenge gets, I hope, signed by the authenticator and then sent back and see whether that confirms with what the backend is expecting. I want to highlight only one more field in this one, which is the sequence of public key credential parameters, which defines which algorithms the authenticator should be using in order to create the public key. This one looks a bit like this one. So it's a dictionary. You can think of as a JSON object, right, that has a type and an algorithm. The type is, I ignore DOM, but it is a string, right? But the algorithm is a cozy algorithm identifier. Let's dive down this rabbit hole, and I'm hoping you're here for me with it. What is cozy? Well, it's a CBOR object signing and encryption thing. So this means it is a registry where I can see which algorithms are defined and which algorithms I can use. Again, excerpt from the registry is beautiful numbers like -268 stands for ESB 512. So you put there a -7, so you get the elliptical curve as an algorithm to use your to create your public key credentials. Okay, so now I know how to create my public key credential parameter to create the credentials. I need the algorithm, right? But there is another thing that is standing in this beautiful recursively name. It's CBOR. Anybody in this room has heard CBOR before? Right, I see some hands. Okay, cool, cool. It was my first encounter with this one when I started working at the company, and it's the concise binary object representation. So it's defining how the interface between an authenticator and our application defines their binary data. So you're not sending over XML or JSON to the authenticator, but you're actually using CBOR. And just quoting their website, CBOR is the format that has been designed to be stable for decades. Well, let us see about this one over time. Because what it does nicely is it defines its type in binary, right? So like think of it of JSON, but actually in binary, so it's getting a bit smaller, and every type is encoded with the first byte that represents the value. Okay, exceptions, I come to them in a second, but if we are looking into the middle of my slides right now, there is the IETF, right? That is a string. And if you look at the binary representation behind it, it starts with 0x64. 64 is the identifier for this is a string of 4 characters. That's 60 stands for string, 4 is the length of the string. And then we have an ASCII encoded 494554 and 46. Well, that's IETF in ASCII. And you can like iterate through this some more and prove me wrong afterwards. But the idea is that like every type we are using to communicate with the authenticator is be represented in CBOR. So we have lists, we have strings, we have numbers. We have kind of weird numbers if they're bigger than 23, because 23 is a constant. We can just put it in there as the type by itself. And edge cases I don't want to go into. Actually, I do, but I don't right now. Okay, so it's a binary representation which we can use to communicate with our authenticator. Great, but how do we communicate with the authenticator, right? We have the format defined. We know now how our like representation would work, but we don't even know the data, the types, the messages, the things we can do with it. Luckily, FIDO Alliance together with WebAuthn defines CTAP, the client to authenticator protocol. This is like it says, right? The thing that we are using to communicate with the authenticator. And just a reminder, an authenticator is either a hardware token or something built into the OS or whatever you want to see. If it is a hardware token, it's specified as an API in scare quotes because it can't be an API because it goes over different transport means. What's a transport? Well, it is USB, NFC, or BLE. Think about, no? BLE doesn't work anymore. I'm just going by specification. I'm completely out of reality. Okay. Okay, then in brackets BLE, but for the point here, it's also, this is a transport, right? We cannot define the same API across different ways how we are communicating with an authenticator. Because, for instance, the USB communication is HID, like human interface definition. So it's essentially if you plug a USB authenticator into your phone or your MacBook or your laptop or whatever, it is a keyboard. And then it uses the keyboard internals to actually communicate the methods and the CBOR we were talking about before with the authenticator. But the same thing wouldn't work on NFC because there we don't have, there is no NFC keyboard I'm aware of, which would be a kind of nice idea, but that's a different talk. So it needs to use the APDU command style, to communicate with NFC. And then BLE, we don't go for this one, but there is something maybe in the standards about BLE that is like yet another way how it would be able to communicate in older versions. So that's why I said this client to authenticator protocol to communicate with the authenticator is an API by specifying only what is able to be communicated, but not necessarily how, because the how is dependent on the communication channel. Okay. So now we have CTAP. Let's take a look at what are the actual things we can do inside the CTAP CTA protocol. So what are the method names, right? So we can make a credential, we can get the credential or the assertion of the credential, If we have multiple ones, we can get them iteratively after each other. We can get information about the authenticator, we can get the client PIN, and we can reset the whole authenticator. Those are just the method names. They're represented by, again, binary values. And the parameters you would give it to those methods are then also, again, CBOR encoded so that you can like bubble it up into the chain of dependencies, communications, protocols. I'm racing through my slides, as you can tell, because I'm just so excited about like going down the rabbit hole. But let's go this way through it once more, right? So we have our app defined. We have written an app. We have a client on the website, or in my case, an Android app that understands WebAuthn, right? It knows which calls it needs to intercept or what can be happening from the website. Once we have gotten from the website or our backend information that we want to create a new credential, or in this case, a passkey, we find out which way of communication we want to use with our authenticator and establish them, right? So like USB, we don't have to do a lot, but with NFC, we kind of need to communicate with the device, hey, are you there or not? BLE, you know. Then once we have this communication and the transport is there, we identify what are we actually wanting to do, right? So what is the C-type API we want to use to communicate with the authenticator in order to create a credential. Once we have this one, we can now take this into CBOR. I already forgot the abbreviation, something binary to make it very easy to go over the wire, and start communicating this CBOR over the wire to the authenticator. And communicating over the wire, in this case, can also be without the wire, and also needs to be incorporating things like chunking because the frame sizes are different, or everything low level we don't want to worry about right now. Actually, I do, but I'm way too fast for this one right now, and I'm happy to have any questions afterwards. Once we have communicated with the authenticator does its magic. It creates the credential, it iterates on the credentials, it does whatever we want it to do, and gives us back the public key of the credential created and the challenge it's just solved, coming in also from the backend again. Once we have the authenticator response, we can now ask the Android app to give it back to the server. The server verifies whether the challenge is there, the public key is not used somewhere else, and other shenanigans, and then can actually tell the app, like, hey, your user is now logged in, please show the logged in phase. Ta-da! That's the whole flow. That is everything that I could come up with on protocol side that you might need to consider if you want to implement it by hand. You probably feel where I'm going with like this one. It is like, do you really want to? And if you want to, great, please do the whole chain by your hand, but also feel free to ask for help and maybe take a look at libraries out there that can help you from parts you don't want to implement yourself. Like I said, there are a lot of parts, right? Bluetooth, like I keep going back to this one, it's a great factor because like, yeah, you might miss things, right? I just didn't realize that this is a thing that we don't do anymore. But also I don't really know how fun it is for you to re-implement the binary representation. Like it is a nice algorithm, but I think people have done it before, let's be honest, and I don't know if you want to spend the time there or somewhere else that actually fits you more. Also, you have like all of the hardware specifications and details to consider, like how does NFC work on Android versus Mac if you want to implement it cross-platform, how do those things differ if they are. But like I keep mentioning, I also like that this is something that is out in the open, right? So like if you want to, you can go crazy. The public specifications are that, they're public. They are there for you to read and implement them, which part of the stack you like. And what I wasn't able to get into, like there is way more, right? So I was mentioning about the challenges, but there are also like extensions you can use in WebAuthn, right? So like you can ask the authenticator to like sign a document or anything from me based on what the authenticator offers as extensions. And then you also obviously have platform authenticators. Those are the things built into your OS or your browser. I'm sorry. So it's another avenue for you to explore if you want to, because it's a different way of how those passkeys are getting generated. And now I'm racing through this one, and I'm so sorry that it was too fast. It was planned for 10 minutes longer, but I'm happy to have any questions and all of your questions you have. Also, if you feel free, if you don't want to speak up or raise your hand, we have a matrix channel. Feel free to ask them there, and either now or later I'll answer them. Any more Bluetooth questions? No.
It's just confusing because there are other Bluetooth authenticators that worked on Android.
Mm-hmm.
And it never implemented. It worked in Android 13, and somewhere down the line, kicked it out. Options completely gone. It's history.
So like the replied answer for the stream was also, right? So like at some point they were existing, but now they aren't. Android had it, now it's not. Down the line, it does not work anymore. We don't talk about the Mac release, okay.
No, it was a minor release of
a minor release.
It was not even a major release that moved it.
Interesting.
That's a little bit annoying.
Happens. I saw a hand over there somewhere. Hey.
Could you explain a bit more how it works with, for example, you can have passkeys with Google, for example, Google Password Manager, and with fingerprint or like screen lock. How it works?
Yes. So the question is, how does this work with platform authenticators? A platform authenticator is the Google authenticator. It could be a password manager, but it could be also OnePass or the others I should not mention by name. Thank you. So they are hopefully implementing the WebAuthn specification. So like up until this stack, it's the same, like from what I was explaining. But then if the create call gets in, they're doing their own magic because they don't have to talk to the hardware or anything. They just talk to the SSL libraries or they need in order to create the public key and send it back to the website. Sorry, that's very rough, but it's as an entry point, hopefully helpful. Thank you. Then I give you 3.5 more staring at you seconds. I think it was 3.5. Thank you so much for your attention. Happy to talk to you further.